Welcome to the sequence of sessions on computer science concepts. I'm Guru Rajan. One of the first things we do or think about when we try to solve problems using data structures is the idea of linear and nonlinear data structures, using linear and nonlinear data structures. So let's see quickly what it is and how it can be used in problem solving. So the idea of a linear data structure is it has a unique successor and a unique predecessor. So what I mean is you can sequentially access the elements of the data structure. You can traverse it, you can sequentially access it. But if it's a non-linear data structure, you cannot sequentially access it or sequentially traverse it. So the examples of sequentially accessing it or the data structures that can be sequentially accessed are queue, array, stack, or a linked list. And the one that cannot be sequentially accessed are trees, graphs, and other nonlinear data structures. So as you can see, you can access this sequentially, whereas in a linked list, you can also access or traverse this sequentially, but there is a subtle difference. In an array, the elements are stored sequentially also. They are also stored sequentially and they can be accessed sequentially. But in a linked list, they're not stored sequentially. They're stored far apart, but you can traverse them sequentially. But still, you can go through them sequentially. Hence, it's a linear data structure. The other thing that usually applies for a linear data structure is they all are at a single level. They're all in a single level. Whereas in a non-linear data structure, usually there are multiple levels involved. So let me show you with an example. So in a linked list or a stack, you only see a single level. But in a tree, as you can see, you have multiple levels. In a tree, you have multiple levels. Similarly, in a graph, you have multiple levels. In a stack or a queue, you only have a single level. So that's another difference you find between a linear and a non-linear data structure. The other thing that is of significance here is what you call the big O notation. We will have a different video for looking at the big O notation. But the time complexity of insertion, deletion, or searching through a new element in a linear data structure, it increases with input size. As the input size increases, the time to search, delete, or insert a new element in a linear data structure is also increasing. It increases with the input size. But in the case of a non-linear data structure, there is a slight improvement or even a marked improvement. In a non-linear data structure, the time doesn't increase linearly with the input size. Even if the input size increases, the time taken to search an element or delete an element increases less with increase in input size. Probably it may increase the log of the size of the input, or it may just increase constantly with input size, like in the case of a hash table. Hash table is a very unique data structure where it has a big O of 1, which means that the increase in time remains constant irrespective of the input size. This is the classification that we usually talk about. Linear data structures contain arrays, stacks, queues, and linked lists. Non-linear data structure consists of graphs and trees. And you can also include the heap and the hash table. They are also non-linear. So the three things that apply for a linear data structure are they are usually at a single level, and their elements can be sequentially accessed or traversed. The other thing is the time complexity of insertion or searching a new element in a data structure often increases with increase in input size, whereas for a non-linear data structure, it doesn't increase as much with increase in the input size. So if you are aware of this, then we can think about different ways of solving problems using data structure. The other subtle thing which I mentioned also is significant. In an array, the elements are also stored in sequence and they can be accessed in sequence. But in a linked list, the elements can be accessed in sequence even though they are not stored in sequence. Hope you got an idea of the difference between linear and nonlinear data structure. Let's look forward for discussing a new concept in computer science in our next video session. Thank you.